Welcome to the latest episode of the MFG Radio Network's Manufacturing Matters, where industry experts take deep dives into the latest technologies you need to consider to keep manufacturing moving. Hello, and welcome to our latest roundtable discussion, details and insights on advanced machine tools. I'm Jake Kaufman, an associate editor for GIE Media's Manufacturing Group. A group of experts, meantime, is standing by waiting to answer questions about the latest advances in machine tools and what benefits they can bring to your operation. We'd like to thank our sponsors for today's roundtable: Anka, Mitsui Seiki USA, the Sharon Group, the Shute Corporation, Matsura USA, and WFL Milturn Technologies. And before we get to today's discussion, let's get to meet our panelists a little bit better, as we are joined by Thompson Matthew. He is Anka's lead software expert and currently works as a software MX product manager. Since 1997, he has worked with customers as an application engineer to find solutions and test the limits of Anka's software products to design and grind the best tools in the market. We are also joined by Eric Wold, Northeast Regional Sales Manager for Mitsui Seiki USA. He began his machining career working part-time in his father's machine shop for 20 years, eventually running day-to-day operations as vice president. After leaving the company business, Eric worked in the aerospace and medical industries before becoming an applications engineer at the Connecticut Center for Advanced Technology, before moving into sales management, working for Yamazin for 2 years before he started his career with Mitsui Seiki USA. Simon Knecht is the VP of Sales and Marketing for the Sharon Group, an accomplished and driven professional with over 20 years of experience in the manufacturing industry in the US and Europe. Jeffrey Reinert is the president CEO of the Shute Corporation. Jeff brings over 30 years of experience to the table, involved in all aspects of manufacturing, sales, marketing, and management to the machine tool industry. And with a career spanning more than 35 years, Billy Bogue maintains a senior level leadership experience and a proven track record in the machine tool industry. Bogue is responsible for sales and marketing at Matsura USA, developing a team of sales engineers serving various geographies and industry segments. And finally, Ben Badgerly began his career in the machine tool industry 44 years ago, opening crates in the warehouse at Hermes Machine Tools. Ben has been active in applications engineering and sales for different builders in both America and in Europe. He's held position as manager of application engineering, sales, and product management for the Mach Company, or for the Mach Corporation, for 10 years, and he has been employed with WFL Milturn Technologies for the past 19 years. So, gentlemen, it is great to meet all of you and see you today. So we will begin today's discussion as we head over to Eric with Mitsui Seiki USA. As I ask Eric, what is the role of Industry 4.0, or the industrial internet of things, when it comes to designing, manufacturing, and even selling today's machine tools?
I think with that one of the interesting things coming in the future with AI is going to be how we sell machine tools. I think it's going to be a lot of changes on how that happens in the future. As far as Industry 4.0, that's something that's going to be very relevant in our industry at the moment. And going forward, it's just only going to get more and more involved.
Okay, awesome, Eric. So we also then head to Ben over at WFL Milturn for the same question. When it does come to Industry 4.0 and the industrial internet of things, what role does it play in the designing, manufacturing, and even the selling of machine tools?
Well, from our end, it hasn't played a lot of role as far as the designing goes. Obviously, in the selling, there is a factor, just like Eric says. The way I see it, there's been a lot of discussion about it, a lot of hype about it, but not quite as much when it comes to actually implementing it. And what I see a lot of is the IT departments of many companies are limiting what the users can do with the Industry 4.0. I have many customers, their IT department will not even let them connect the machine to the internet. So if you can't connect the machine to the internet, Industry 4.0, it doesn't really mean a whole lot. That's what I see in it. I think there's a ways to go. There's a way to go in the culture. Let's say everybody wants to keep their business secret, but they want to see everyone else's.
Awesome. Thank you, Ben. Now we also head over to Thompson over at Anka. Now, Thompson, what do you guys see as far as the industrial Internet of Things in Industry 4.0 when it does come time to make, sell, even develop these machine tools?
Yeah, I kind of agree with a little bit of what Ben said. We also have something on the machines, as a production and machine monitoring software to collect data from the machines. We have two versions of this. One is on-premise. As Ben said, if customers don't want to let their secret out, they can do it on the premise, and we have a cloud version. So we've managed to get some customers on the cloud version, and we've collected a lot of data. And what we do with that is we incorporate that into our machine design. For example, we know how long our spindle runs, or what torque or what load is being used, and or the wheel exchangers, how often they fail. So we get all this data, give it to our designers, and the next version or the next machine when they design, they make sure that all these faults are put into the same design. And that's the way we work with the Industry 4.0.
Awesome. Thank you, Thompson. And we'll wrap up this round of questions with Simon over at Sharon. Now, Simon, when it does come to using Industry 4.0, how can it be incorporated into modern machine tools?
So from our side, I always take a simple approach when I think about Industry 4.0. There's the one side, yeah, you can get a computer gain on an app and you like it and people like it and they all get it. But we talk about manufacturing here, and the really goal of manufacturing is when we talk about software and new technologies, like we want to do things better and more simple. So we don't want to deal with stuff. We want to do things better. And our target at the end for the customers to do good parts and make it fast. So we have to focus on what brings the solution to our customer that simplifies that process to make better parts, good parts, fast parts. That's the ultimate goal, and that's what we have to focus on. Yes, at the shows these days, you see a lot of gadgets, and like, I can look at, the spindle was running 15 hours at that RPM. Does it help me anyway in this situation? No. So I think that becomes key to focus on what is really getting our customers forward, and customers think about that topic when they buy a machine. What really helps me get more productive, get more quality, and I can see that going forward. Everybody comes up with their solution. Customers also don't want to install, 15 different softwares on their PC, get the license for that, and then need another person just to run all of that. It needs to be simple. So when it comes to that, my topic went into like tool management. This is a big hassle, people running around, manual tool presetting, and then typing the data into the machine. What's the tool length? There is things that automate that these days. I don't want to make commercial for anybody here today, but there's tool presetters that automatically load with a QR code, store the data, goes on, travels to the machine, loads it automatically. And so these are the things that we have to talk about. How do we help our customers automate things and get the next step forward, not just to put fancy gadgets out there. So stay focused on that. Yeah.
Gotcha. Thank you, Simon. We'll go to the next round of questions as we head over to Billy from Matsuura. And I ask Billy, how is automation, robotics, and artificial intelligence being used in modern machine tools?
Thank you, Jake. Took the mute off. Yeah, I think, outside of the simplest safety concerns and the improvements from a safety perspective, from reliability perspective and productivity, I think right now that automation and robotics is centered around labor cost reduction and increased labor productivity. I think if you went and polled most manufacturers right now and asked them what their number one problem is, it's going to be around obtaining and keeping and retaining skilled labor. We haven't recovered from the pandemic. And if anybody's been in the industry long enough to know, even prior to the pandemic, we saw this trend coming. The labor force in the manufacturing world has been on the decline. I don't know if it's not sexy enough to be a machinist anymore, or if the trade schools can't keep up, or if the culture's changing, but we've been on this trajectory for quite some time. And then to compound that with, it's a competitive global marketplace right now for manufacturers, and understanding and take advantage of automation and doing things lights out and running unmanned. As some people have figured out, that's about the only way they can compete in certain respective industries. You're not going to be productive enough if you're paying someone to stand at the machine and change parts on a daily basis. We think about it from Matsuura's perspective. 30 years ago, we introduced our first pallet machine, and they probably looked at us like we had 10 heads because it wasn't as mainstream as it is today. But I think most builders that are respectable now in the world have some type of palletized or automation or robotics cell that they can somehow, interest the customer and help the customer gain its productivity. Whether it's a pallet system or robotics is really good because it's got the end of arm tooling can allow you to change parts, the same part, high volume, and you do it repeatedly because, the robot doesn't call in sick. And usually when the robot is tuned in and accurate, it's technologically sound, it doesn't make mistakes. So, the scrap rates are reduced. It's all a productivity gain at this time. I think AI is a little too early. And I think Eric and Ben and some of the other groups had already talked about the AI, and it is trending in the right direction. Thermal compensation, AI, compensating for the environment, those things are coming. But I think right now, the automation side through pallet systems and robotics, and as we attack the labor challenges that we have here in the manufacturing sector, are probably predominant right now.
Awesome. Thank you, Billy. So Eric, we'll go back to you with the same question. When it does come for automation and robotics, artificial intelligence, how are you seeing that being used in modern machine tools? And also, what does that mean for an individual worker then, if there is all this automation and robotics available?
Yeah, and I'll add a little bit to what Billy just said. It's, he's right spot on about the employee problem with all manufacturers. Every manufacturer is going to say the same thing. We can't find people. But I think with automation, robotics, I think you're going to find a different manufacturer in the future. One where you might have some very low skilled people who are tending machines, removing materials, adding raw materials to cells, and then have a higher level engineer worker who has been more working on building a stable process built around automation. So I just kind of see that in some of our companies that we work with that are more on the cutting edge, where the traditional machinist standing at the machine tool, even programming the machine tool themselves, I think is something that's, going away to a degree in certain areas, even in aerospace where we work quite a bit, where it's, very demanding parts, demanding tolerances to be held. I think they see more of the benefit to having a very stable automated process that repeats consistently and have lower skilled workers who are loading, unloading machines, and then more engineers who are driving the process, more on an engineering side than a hands-on machinist side.
Okay. Awesome. Perfect. Thank you, Eric. So Ben, we'll ask you the question when it comes to automation and robotics. How is it being used in modern machine tools? And also an individual worker, what is the impact that they have when there is so much automation and robotics?
Yeah, I mean, both Billy and Eric have good points, but we look at it in a little bit of a different way. If anybody's familiar with WFL, we're not making extremely high automotive volume parts like brake rotors, for example, right? We make very complex work pieces. Sometimes the work piece might be in the machine for a month, or a week or a day. But that being said, we see a lot in automation, so much so that we actually bought an automation company. We now own an automation company, which makes robots, gantries, and all types of automation integration. But you also have to define what is automation, because even with parts that take 3 or 4 or 5 hours, we're still getting requests for automation so they can run lights out for maybe a weekend. They might only get 5 or 6 parts over the weekend, but it's 5 or 6 parts without any labor cost. But also, how do you define automation? And I can give you just a real quick example. We had a customer with a work piece that was taking them a month and a half to make it. And it had nothing to do with cutting time. It was just work pieces sitting on the floor waiting for the next machine. first to a lathe, then to another lathe, then to a machine, then to a boring mill, then back to another lathe. We were able to take that workpiece, do it in one clamping, one loading, one clamping, door closed in 13 hours.
Okay.
And this had nothing to do with cut time. This was all about work in process. So you could also say that's automation.
Yeah.
Right. So how are you defining automation? Right. It's overall productivity, like Simon said before. It's overall productivity. If we go from a month and a half to for a finished part to 13 hours for a finished part, that's automation. Even though the part was loaded manually with a crane. Right.
Awesome. Cool. Thank you, Ben. So we'll wrap up this round with Thompson with Anka. Now, when it does have automation, robotics, and even artificial intelligence, how are those being used in today's modern machine tools? And also, what does that mean for an individual worker?
Yeah, I actually totally agree with Billy and Eric. In the skilled labor shortages, we have the same problem. I mean, we make tool and cutter grinding machines, which needs an operator, standing in front of the machine for full shift because he's continuously loading. I mean, even if there is a robot in the machine, he still does that. So the operator jobs like operating machines, programming machines, transferring tools, compensation, etc. So what we have done is we've actually now come to the market with a new product which Anka has launched, and it's called AIMS, Anka Integrated Manufacturing System. That's what we do. So what we do there is we employ advanced automation, including robots as well as machine learning, and we try to automate the complete tool grinding process from blank to a finished tool. So what happens with this system is where all processes like material transferring, grinding, measurement, compensation, laser marking, all these are orchestrated by a single brain, and we call it the AIMS server, which is the brain of the system, which is connected to the ERP systems. We've just launched it and started selling it in the market. So the benefits are, you're not relying on skilled operators anymore, and we wanted to, and this is actually expandable and based on the customers, we could make it into a bigger system or a smaller system. So this actually maximizes your machine uptime, eliminates human error, and reduces scraps. So there's a lot of benefits in this system.
Awesome. Thank you, Thompson. So we'll go to Simon for the next round of questions, which does kind of play on the automation and robotics and things like that. But with more and more technology being used on the shop floor today and with machine tools, what is the learning curve of a worker and what kind of training is available for the workers once they do get in or onto the shop floor?
Yeah, so in today's, what we see in today's market, the technology level is really far advanced in the different industries, and it's fascinating. It's fascinating to see what we're able to do, what we're able to accomplish. But then you're talking about, okay, now we're gonna start it up and engineer design something. Now we're gonna bring it to the customer. How do we bring it down to have a decent learning curve? Because people don't have like 1 to 2 years to train operators and then get in. So the classical approach is like, yeah, we do an operator training for a week or service class, or even a production support on larger systems that were there for a month. So these are very practical approaches. But I also think we need to look at that going forward, and each plant has to do that because we're one machine supplier, but on a blend level, sometimes companies have 4 or 5 different machine types, grinding, mill turns, milling machines, whatsoever, and they all require a technology level. So it almost seems that when you look at the different aspects, how to keep a machine running, how do I solve my problem? Is there an overall, not software tool, but approach that customers can use? Hey, here I have a PDF manual from supplier A. What do we do with that? Do we just look it up? Somebody sits at a PC trying to solve the problem, or can we use better technology when it comes to maintenance? So hey, the machine can tell me this is up, and develop in that direction to get the learning curve quicker. But we also have to adapt in how we break it down to people, because we have to make it simple and keep it simple. And that's, I go back to cell phones. Cell phones have a lot of technology in the background. They do stuff, they have sensors in there. But the front end, I don't read a manual anymore for a cell phone. And it's maybe not that comparable, but that is where we have to invest and look at and working, and actually it's with some end customers, because it could be an automation cell that's completely customized, designed for the customer. With special features in it, barcode scanners that read worksheets and then pull a CNC program to do the right part. We do that these days. But how do I simplify to a customer? These are steps that we really need to take. We're taking them because customer requested. How do I have 15 different part programs and make it simple that when I get this work order, it pulls the different macro programs together, where the operator doesn't even have to think much about, hey, what's happening in the back. The back end can be complicated. We invest in that. We do that here at the factory. But then the front end at the customer needs to be simple. And that's really a key approach that we can't forget. We can say, oh yeah, that you need the skill. And I was like, well, I can't train a person for this type A, type B, type C. I mean, we're going to spend years on just training to understand the different technologies. So we're all in the same situation where we have to make it simple, keep it simple, what we design and what we set up, but also on the customer level to say, hey, how do I organize my shop floor to make it simple for my operators, maintenance steps, and work with the machine tool suppliers, automation suppliers to bring it down to that level, because there is some customization involved in that. Yeah.
Awesome. Thank you, Simon. So judging by my screen, it looks like Eric will be up next with that question. What is the learning curve like for a new worker with all the new technology in machine tools, and what kind of training is available for a worker once they do get a job in the machine tool industry?
So a minute ago, I think we were all talking about what was the customer's biggest problem was finding people. I think if you ask them what their second biggest problem is finding skilled people or training people within their industries. I think from a machine tool builder side, we provide training to the customer, but I think there has to be more of a partnership with the customer, because just because training happens over the course of a week or 2 weeks on a machine or a system, it doesn't mean the training is going to stay with the people that got trained. I think there has to be a partnership where the training gets moved to the customer, and the customer has a part in training the employees, the new employees that come in, so that a lot of that knowledge isn't lost. So that's going to be one of the struggles is, how does the company do training? That's always a difficult thing. I think a lot of companies in the past have relied on maybe larger OEMs who have had apprenticeship programs, and then those people get fed out into the system over the years, and a lot of that's gone away. So working with the machine tool companies or any company that you work with and having some kind of internal training in your company so that all of that kind of gets captured for the next people coming up, I think is pretty important these days.
Awesome. Thank you, Eric. Now it looks like Thompson will be up next, judging by my screen. So Thompson, at Anka, with more and more technology being used, what is the learning curve and what kind of training is there for a individual worker?
Yeah, we kind of have the same problem at Anka because we sell machines globally, and everywhere we go, we send everywhere the machines are sold, one of our application engineers have to go train an operator or somebody. And then after a month or two, we hear the operators left the business. We need somebody else to come and train us. So this has been an ongoing problem for us. And one of the solutions we have come with is what I spoke about before, the AIMS, the Anka Integrated Manufacturing System, where we actually get support because we sell a lot of robots and automated systems. We actually contact those people as well, and they would go in and train the existing people or the people who have left, on the robotics and the other side of it. So the training from our side becomes much easier for us because we started distributing and splitting the training to individual component suppliers. So that way we have been a little bit better off, not much better off, but a little bit. And the other aspect is COVID has actually, in a way, helped us. I mean, I wouldn't say helped us in a large way, but because we are an Australian company and we sell machines globally, we were unable to travel during the COVID time. So we started, offering online training courses and, getting into machines using TeamViewer and offering training. So that was a benefit to us. And that system was developed during the COVID time. And that's coming into practice a lot these days as well.
Awesome. Thank you, Thompson. So we'll go to Billy from Metsera once again with the same question. When a new employee does come on, what is the learning curve and what kind of training is available for that employee?
Thank you, Jake. Yeah, and as the others mentioned, it's a great segue back to labor for sure. With the skill level deficiency that all of our manufacturers are challenged and faced with. One of the things at Metsera, instead of focusing on the new mousetrap, we've decided that focusing on the ease of use and getting better and making our machines better and more easy to use and making more user friendly is one of the core focuses moving forward. Because of that, we listen to the market and understand that the labor force deficiency, like Eric mentioned earlier, the days of the guy that used to sit in the programming office, write the program, write the code, go out and load it on the machine, plug it in, hit cycle start and make his own part. Those are few and far between, if not almost, irrelevant at this point. One of the saving graces for us is that we partner obviously with FANUC, a pioneer on the controller side. So, and it's commonality from one machine to every machine has the same control, regardless of which Metsera it is. And it's a Windows-based software. Mentioned that Simon talked about the cell phone. That's a great analogy because you want to make the machine tool as user-friendly as possible with hot buttons. It says tool offset, tool probe, go do this, go do that, because we don't have the skilled labor anymore standing at the machine diagnosing what's going on. The technological advances are there. We just have to make sure that we can recognize that, if people can typically run a computer, they can typically figure out and learn something about the machine because it's Windows based. And the other thing is there's so many more automatic macro cycles now. We have to make this and I'd be careful how I say it, but you have to make it in its simplest form for some of the skilled labor or less than skilled labor, because the turnover rate, as everyone's mentioned, is tremendous right now. And having the ability to train, as Thomas mentioned, as well as Simon, you're there for a week or two and then you're gone. And then, the next thing the customer's got 2 new guys that started or people started and they have to go. And then, from a builder's perspective, the challenge for us is how many people have gone into a shop that you have the right fit, you're probably the best solution, but the settling for the status quo comes into play because they don't want to have to train on a new control. They don't want to have to train on something that's unfamiliar. So they're going to make do with what they have, and they become builder, committed because they don't want to worry about changing controls and having the learning curve. As far as training goes, we mentioned it. I kind of mentioned it before. I went through an apprentice program right out of high school, 4-year apprentice program, and they still exist. They're just not as popular anymore. We're fortunate here in Minnesota that we have Anoka, Hennepin, St. Paul College. There's still quite a few technical schools out there. I just don't see culturally, we're not getting the receptiveness that we used to have in the past about going to a trade school out of high school versus, going to college and doing something different.
Okay. Thank you, Billy. And then Ben, we'll have you wrap up this round of questions. What is the learning curve for a new worker and what kind of training is available for that worker once they do get into a machine tool builder?
Well, I mean, everybody so far has had really good points. And I think there's something that's unsaid. Everybody's afraid to say it. And that is that training cannot be the sole responsibility of a machine tool builder, right? And that goes for any industry and any product and any kind of builder. The common thing you hear is you can't find the people with the skills that we need. You hear that the schools aren't preparing the kids for the skills that we need. But guess what? They never did. This is nothing new. All these big companies and a lot of small, medium companies used to have an apprenticeship program because the schools did not prepare the kids for the skills we need. I'm sure Simon's company has one. We have one. We hire 10 to 15 new apprentices every year. We start them at 15 years old. The number 2, number 3, and number 4 man on the totem pole at WFL started at my company when they were 15 years old. I had a customer said to me when we had 2 guys installing a machine, they were 19 years old. And he was absolutely flabbergasted at how in control they were. And he says, my God, where do you find these guys? And I said, that's your problem. We don't find them, we make them, right? So, you know, expecting the schools or expecting someone else to do it for you is kind of a crutch. I know it's expensive. I know it's not easy. I know there are some serious problems with finding good people. But we have to take it on ourselves to make it happen. I mean, most of these big companies, they have no problem paying a white collar worker to get their master's in accounting. And guess what? They leave. Sometimes they leave. That's life, right? But then the first time they spend money to train an operator and teach him about machining, because all this technology means nothing if he doesn't recognize when a tool is cutting bad. And then as soon as they train somebody and he leaves, they say, that's it, we're never doing that again. It needs to be said that, you know, you look at what Titan Gilroy does. The man's amazing, right? He sees it. So I just wanted to add that.
Awesome. Thank you, Ben. So we will go back to Thompson at Anka for our next round of questions. Now, if you have a customer that wants to enter into a new industry, is it easier to retrofit their existing machine tools, or would you say that it's easier for them to buy brand new machine tools for that specific industry?
We get this all the time. You know, about 50% of our machines are customized, and 50% maybe, you know, we still standard machines. And also it depends on the scope of changes, what they ask for. But the fact is Anka is vertically and horizontally integrated. So when I say we are vertically integrated, we do our own software, we do our own drives, CNCs. We don't depend on third party for even the safety units or CNCs, everything. So Anka has been vertically integrated right from day one. So this makes it actually a little bit easier for us to customize the machines or even make new machines for our end users. And we are known as a tool and cutter grinder company, but we play a role in every market. The medical industry, you want to do a rasps or a knee joint, we are prepared, you know, to convert our machine to do that. And we have a software team, and we are easily able to make changes because we've got the source code. We can make the changes to the programs and supply it. We do fixturing. We have a special unit, you know, we can make and convert machines, and we do new machines as well. So the advantage we have is because of the flexibility of our software and because we are vertically integrated, we are able to change or, you know, retrofit the existing machines or make a new machine. So that's something we do all the time.
Awesome. Thank you, Thompson. So Simon at the Sharon Group, we'll go back to you with the same question. Is it easier for you to retrofit an existing machine for a customer to get into a new industry, or are you able to sell them brand new machine tools in order to use in that new industry?
I think it comes back to the individual task that the customer wants to accomplish. So in nowadays age, we talk about sustainability. So to keep existing equipment running is always the choice for sustainability. And part of our business in the Sharon Group is used machine tools. So we take machine tools back from customers. Mostly it's a lot of automotive, you know, that want to invest in faster equipment, 20-30% gain in productivity. And then, but these machines tools, they find a home then in some other markets where it's not high speed, where customers just need to drill a bunch of holes and do some parts, and that's where the machine goes. So for the life cycle, this is a good concept. For the individual company to, when they stand in front of that decision, they have to these days put in some soft factors too into the calculation. Not just a new machine tool cost me this much, refurbishment cost me that much, or use the existing one. So you have to dig deeper, you know, and goes down to electricity consumption. Do I gain 20-30% in productivity? You know, if customers has a product change and he has 4 or 5 machines, and you gain 20-30% with new equipment, or have the technology to go to, let's say, a mill turn concept where I can do the part faster, better, automated, or go to a multi-spindle where I currently do it in a single spindle mode. I do it in a twin mode. So these are the things you have to look into and do the calculation on a case by case. I don't think there's a general to say, yeah, a new way is better. With the shift currently of the e-mobility, yeah, there are some hard factors where you say, okay, my engine block, this certain size, I go to structural battery trays housings. This is a change in machine. So ThyssenKrupp always emphasize to make the machine tools flexible for the customer. And this is in some cases you don't get around with a new machine tool. If your part size is just 700-800 millimeters aluminum structure and you need speed to finish the process because you need to buy a bunch of machines, then the path is clear. But there's other situations where you have to consider the soft factor of that. Yeah. So
Awesome. Thank you, Simon. Now it looks like Jeff has been able to join us. We will be able to get his answer from Shute as we ask, is it easier to retrofit existing machine tools and machines for a customer that's about to enter a new industry, or is it easier to just sell them brand new machine tools across the board?
There's several sizes to that question, and I do apologize. Our internet provider here has decided to take this exact moment in time to go down with technical difficulties in and out here. In any case, the current state of machine tools, our newer models of machines, are all designed with many features and many functions so that they can be updated, reconfigured, retooled, and compliant with all industry standards, including what you've undoubtedly already talked about, the Industry 4.0. So we can connect to different networks, company networks on a variety of softwares. We can monitor all of the data, the parts, the operational status, and so on and so forth. But your tooling vendors and your fixture vendors and all of the other parties involved in our industry, we all work together, don't we? We all have to be compliant with the various tool interfaces, your standard, your VDIs and your HSKs and your CAPTO systems and so on and so forth. And this all helps us retool and reconfigure our machines quickly. It also lets us have our equipment set up in such a way that they can be the tooling and everything can be measured offline and prior to being presented to the machine tool. Your redundant tooling can also be in position, all pre-measured. So the delay time between one part setup and another part setup is minimized. This all has to be taken into consideration so that your machine tool can be kept in production at all times. The more complex we get in our machine tools are probably on the more complex side, with some of our machines having more than 64 simultaneous axes. Mm-hmm. You don't set those up for a typical 2-axis cut, but there is obviously more involved. There's a much higher production rate, and so there's much more involved in these tools. But yet we do make them so that they can be changed over as quickly as possible with all of the interfaces and so on and so forth. And so hopefully that helps everybody. We do offer quite extensive training and simulation software to help along these lines as well. So much of this can be done offline and keep the machine tool running.
Awesome. Thank you, Jeff. Glad you were able to finally join us today. Now, just for the timing purposes, we will kind of skip over to the next question, as I will go to Eric once again and ask, with today's CNC machines and technology, just how quickly can a custom project be completed?
So I think that's kind of a two-part answer. There's the technology and then there's the machine tool. I think with the technology of the latest CAM systems, application software where everything can be verified on a machine tool before go to the machine tool actually cut anything, reduces a tremendous amount of time. And then the other thing is having an extremely accurate machine tool when you take that verified code and bring it to machine tool, you know you're going to get exactly what you had cut in the virtual world into the real world. And I think that makes a pretty big difference on moving a project from the beginning to an actual completed part as quickly as possible.
Awesome. Thank you, Eric. Now we'll go to Ben from WFL with the same question. With today's modern machines and the technology, just how quickly can custom projects be completed?
Well, I think there's two sides to that. Are you talking about for us to build a custom machine to do a custom application, or for a customer to apply our machine to a custom project for their
I would
customer?
assume we'll go from the viewpoint of a customer.
Okay, well, it's generally pretty easy, because if you look at our machines today, and most of the people here, with possibly the exception of the Schutte, because it's more of a multi-spindle, we have a tool changer. We have a single tool post with a tool changer, and we have controls now with tremendous amounts of memory. So I have customers, you can be making a crankshaft one day, and you simply call up the program. The cutting tools are already in the tool changer. They change some chuck jaws in the chuck, and they'd be making a jet engine shaft the next day, in literally 10-15 minute changeover.
Okay.
So a lot has to do with how the customer is prepared, right?
Mhm.
His preparation, what kind of tooling does he have? And so theoretically, you could be 15-minute changeover, assuming you have all the tools, in-house, right? So if you have to start from scratch and go out and buy tools, well, yeah, that could take a long time depending on the delivery of the tools, right?
Yeah.
So, and with the new modern CAM systems, you can prepare a program pretty quickly. So you go from, and then a lot depends too on the type of industry you're in. So for example, if you're making a crankshaft on our machine from a piece of bar stock, you can change from one crankshaft to another in literally 5 or 10 minutes. If you're on a transfer line making 100 crankshafts an hour, that's a different thing. It's going to take weeks and weeks to change that over to make a camshaft.
Awesome. Thank you, Ben. Now, once again, just for the timing purposes, unless there is anything else that people wanted to talk about with custom projects and the quick ability to complete them, we'll go on to a product or technology offering that you've come to appreciate that you could say has been most helpful to your customers over the years. So Simon, over at the Sharon Group, we will start with you. What is, a product, a technology, an offering that you've really seen be very beneficial to your customers within the past few years?
So at the end, the goal is for customers to make good parts, lots of good parts. And what we offer to solve that topic is, the flexibility that customer can have, repeatability on the machine. That's a key topic. So thermostability cycles that the machine does automatically, tool management, tool checks, part measuring in the machine. These are the things that really help customers reduce that scrap rate, bring that scrap rate down, and produce a good part. And from a technology standpoint, yes, this includes different components from different outside vendors, machine tools. I always say we put over 1,000 or 500 different articles together in a machine tool and make it work good. And to put that, we have that knowledge how to put everything together and bring it to the customer and give him those advantages. So technology standpoint, right, is a big point, is the tool management. Hey, I realize my tool lifetime is run out. We implemented outside software and technology that can take the tool load. Different programs are out there that are implemented in our machines where customer can detect cut data and then say, okay, I have a tool that is not performing. Lock it, check the part, and then bring out the Sisto tool that we programmed. And then, so these software features help customers to not run into the situation where you come back, oh, I have 15 to 20 scrap parts, I gotta go back. And so those are the little things that add up. You know, our big portion from the machine tool is always to say, we gotta get the equipment and the technical availability 95% and up. Yeah? And it comes down to the different parts. If I drill 5 holes all day long, this is a different task that when I'm chasing 50 SBC features on a machine. So the disciplines change. We depend on the cutting tool eventually. So we have to work with the cutting tool suppliers. It's like what is the best tool to use for that application. So it's different disciplines, but put it together and make it stable. And the technology is out there. We just need to put it together. Right. Yeah.
Awesome. Thank you, Simon. So we'll go to Billy at Matsuura for the same question. What is a product, technology, or an offering that you've really seen become beneficial to your customers over the past few years?
Thank you, Jake. Well, from a Matsuura perspective, that one's fairly easy for us. I didn't have to think long about it. It's the pallet system. It's our own automated pallet system, factory pallet system installed by Matsuura. As Simon alluded to, we want spindle uptime. If the spindle's running, the customer's making money. In order to do that, then we have to be able to run continuously and nonstop. And the way the pallet system worked for us is we have a workstation that we can unload and load parts while the spindle's running. And as long as the spindle's running, the customer's happy and making money. And then we can dig deeper into, as Simon mentioned, this tool life management page and redundant tooling and the pallet scheduling system and things that help this and make it much easier for the customer to keep the spindle running and to make accurate parts and to make them reliably. And I'm also partial to 5-axis. You know, we live in a 5-axis world at Matsuura. So little things like our Easy 5 function, which will run an automatic cycle to make sure that the axes are trimmed and they're aligned and calibrated correctly. And also we've talked about thermal compensation, things that are happening behind the scenes that the customer relies on, depends on, and counts on to happen. And we provide it for them as well.
Awesome. Thank you, Billy. So we'll go to Jeff as well with the same question over at Shute. What is an offering, a product, a technology that you've really seen customers appreciate over the past few years?
We have a system for our simulation and crash avoidance, so we can simulate offline. That saves a lot of time and effort and trouble. But we also have developed, goes back to the connection to the system, to the company system. We have a box, I'm going to just call it a box for right now purposes, that connects to the machine. Many of the IT departments now don't want their machines connected to the internet at all times for security reasons. And so we found that becomes a problem for us for remote diagnostics and assisting customers and keeping their equipment up, because we can't be connected. It also is a problem sometimes for the customer monitoring. So we've developed a little unit that goes on the machine that actually is a recording device. It records all of the information. It records the part data, the operational modes, the real time, the cycle counts, the cycle times, the machine status, all of the different temperatures of the drives. We have also developed, of course, frequency controlled pumps. I think most of our machine tool vendors on this panel also have frequency controlled dives to reduce the power consumption. All of these features and all of this computer monitored points of our machines will record into this box, if I will. And therefore the plant software and the customer can monitor this at their convenience. And if they want to share any of this information with us on their call, they open a channel, and then we can look in and see and advise on what may or may not have helped them and keep them up and running.
Awesome. Thank you, Jeff. So we will go to Eric at Mitsui Seiki USA for the same question. What is a product, a technology, and just an offering that you've seen your customers really become appreciative of in the most recent years?
Well, I think for us, being in the aerospace industry, you know, machining a lot of titaniums and Inconels is are work that we've done through the years to be able to remove material at a much higher material removal rates in those type of materials, to be able to reduce the cost of machining titanium and Inconel has been, tremendous for our customers. And also the ability to hold extremely tight tolerances on finishes for those types of parts has been kind of like one of our major goals that we've worked on through the years.
Awesome. Thank you, Eric. So just a few more in this round as we have Ben up next from WFL. What is, the technology, the product, the offering that you've really seen customers embrace and become appreciative of in the most recent years?
If I had to pick just one, I would say it was probing. If I could have two, it's probing and crash guard. It's taken a long time to convince people to do probing in the machine. I've had a lot of resistance to it over the years. Nobody trusts that you can probe in the machine. But slowly, they start accepting that, yes, it does work, right? So when you have a work piece that may be worth $30,000 and you don't want to be finishing the part and then taking it out, putting it into CMM and find out it's bad, right? So we've developed routines where we will do a test cut, and that way you take into consideration all the tool deflection, tool wear, machine deflection, workpiece deflection. So we'll take a test cut, measure it, then compensate for that final cut, and that way you ensure it's a good part rather than measuring it after you machine it.
Awesome.
And we also develop probing. Now we can measure in the machine. We can measure for roundness and surface finish.
Perfect.
In the machine.
Awesome.
And it's finally getting a lot of acceptance now.
Great. Sounds good, Ben. Thank you so much. And we'll wrap up this round with Thompson over at Anka. So Thompson, what is, a product, a technology, an offering from Anka that customers have really come to appreciate in the most recent years?
Yeah, so that's something quite easy for us because one of the main issues, the problem our customers having was because these tools, the cutting tools are so accurate, they have to measure these tools. So for measurement and compensation, they had to take these tools out of the collet or the collet adapter or the chucking system, take it to an external measurement machine, measure these tools accurately, and bring the data back to the machine, compensate it. And this was a tedious process for them to do. So what we did was we tied up with Bloom Technologies. So we've introduced measurement inside the machine, measurement and compensation. So what this Bloom technology does is, or the laser, it's basically a laser. So the tools go in and it can automatically measure the tools and compensate the tools at the same time. So you eliminate the operator error, of making mistakes, doing compensation or taking the tools out. So the machine doesn't have to slow down or stay idle. And that can also cause problems in stability of the machine. So overall, the compensation and measurement process inside the machine with the laser has been a breakthrough for us, and it solved a lot of problems for the end user.
Awesome. Thank you, Thompson. So next round of questions, we go to Billy over at Mitsura, and I ask you, what is the biggest challenge, problem, or issue that you've been able to solve for customers within the most recent years as well?
All right, Jake, I'm going to keep this one short. Going to surprise you. 5-axis palletization, being able to run the complete weekend. There's a reason why we call it a MAM 72. The full intention was to be able to leave on Friday, come back on Monday. Customers will face this problem, continue to face this problem, paying labor over the weekends, paying for extended hours. So we continue to address it. There's a lot of technological advances out there, but at the end of the day, running the spindle lights out, unmanned, unattended is the most benefit, the best benefit that we could ever supply for our customers.
Awesome. Thank you, Billy. So we go to Jeff over at the Chute Group with the same question. What's a challenge, a problem, an issue that you've been able to solve for customers recently?
It's going to go along those same lines. We've made all of our tooling and our machines, our multi-spindles, we can handle in some cases more than 50 tools in a multi-spindle. We put those in there not because you're going to cut with all of them at once, but for redundancy. Also, the bases of these holders have various, like I said, Capto, HSK, and so on. They're all set up for very quick change, and we hold a lot of tools. We do this so you can have quick changeover, redundancy. You can be in the cut at all times. You can have backup tools in the machine ready to go, so the machine can continue to make production overnight, over weekends, on off shifts with minimal labor to maintain it at all times. Keep the production going.
Awesome. Thank you, Jeff. So we'll go back to Thompson at Anka with the same question. Biggest challenge, issue, problem for customers that you guys have been able to solve recently?
Yeah, there was, I mean, I'll go through a couple of them because, you know, a couple of them have been breakthrough for us as well in the cutting tool industry. So one was the tool run out. Basically, you know, for us, the cutting tools have to run perfectly. You know, we want under a micron or something run out on these cutting tools after they are ground for efficient cutting and avoid chattering and get better surface finish. So we've introduced a software actually into the machine to solve this. Instead of solving it mechanically, we've introduced a software, and we've got a touch probe inside the machine. So the probe comes and probes the tool, and it's able to compensate the tools, and it's a kinematic compensation we apply in 5-axis. So that's one of the breakthrough what we have given. So what happens in this case is customers don't have to spend X number of hours, you know, trying to set up a collet adapter, or, you know, and every tool that comes into the machine can be probed and compensated. The next one, you know, the breakthrough what we did to the market was introducing MTC, which is called as a motor temperature control. So grinding spindles, you know, when you grind cutting tools, it can go at different loads because you are removing material for floating in a lot of material, and for OD or other finishes, you are removing less material, and wheels also run at different RPMs. So the grinding spindle, you know, tend to expand a little bit or, you know, shrink a little bit during these operations. And at the time, we were not able to maintain the stability and the diameter could vary a little bit. So we've introduced this MTC, motor temperature control, which we have patented now in the US. And this actually maintains the stability of this grinding spindle within a few microns. And that way we've resolved that problem of the spindle growth and variations in cutting tool diameter.
Awesome. Thank you, Thompson. So Simon, same question to you at the Chiron Group. What is the biggest challenge, problem, issue that you have been able to solve or address in the most recent years for your customers?
So I name one big one that is shifting certainly from the classical approach. I turn a part, I do the milling, and I have multiple steps to a mill turn solution. Integrating milling and turning into one machine for certain work pieces has been a key. We see that from a massive increase in quality because I can finish features. You know, I can do some turning. I can do all the rough machining on the part, do the rough milling, and then I do the rough boring milling. So all the tension out of the workpiece goes out, and then I do the finished machining. I come back to the deep burring on cross holes. So the mill turn technology has really advanced us and have solved a lot of problems for our customers. Chiron Group does a lot with cutting tool manufacturers, so actually making the cutting tools in export tooling, and that was key. Just tool holders directly from a bar stock, and also from an automation standpoint. When I come from a bar stock, I always have optimum clamping because I can reduce material as I want strategically and define my process down to perfection, and that's what we were able to do. And again, that feature, when you have 20 bars in your machine lined up and you leave on a Friday and you have them running, we've seen that numerous times, and customers love it. So yeah, mill turn is definitely a highlight.
Awesome. Thank you, Simon. So then we go to Ben at WFL Mill Turn. What is the biggest problem, issue, and how have you guys been able to help solve it for customers recently?
Well, in one word, it's a crash guard. The more complex these machines get, and everybody here, like Jeff says, 64 axes, you know, every axis you add to a machine, you add another potential collision, right? So there's a lot of aftermarket systems out there to to try to prevent collisions, but they're only part of the solution. They'll get you maybe 60, 70, or 80% of the way there. But once you're out actually in the machine tool making chips, that's where they lack. We've developed a system that's patented called CrashGuard, which is actually a real digital twin of the machine, meaning that the 3D models of the machine are actually kinetic. So if you see a steady rest open, you actually see it open in the model as well. So you could actually close your eyes, put it in full rapid traverse, manual jog mode, close your eyes, hit the jog button, and you will not run into a chuck jaw or a steady rest or a tailstock or anything. And everybody knows that one major crash can cost you $50,000 and cost you a week of downtime, you know. And that's been absolutely huge. It's an actual digital twin of the machine. And so I have customers that have already commented about how much money it's saved them in crashes, because you have a combination of more complex machines with less skilled workers, which is a recipe for disaster.
Great. Thank you, Ben. And then we'll wrap up this round of questions with Eric at Mitsui Seiki. As I ask you once again the same question, what is the biggest problem, issue that you have been able to solve for customers recently?
Jeff, you actually asked me that question. I was the first one to answer.
Oh, you did? Oh, I'm
Yeah.
so sorry. Well, then, with that same regard, then, we will start wrapping up with our final question of the roundtable, and I will stay with you, Eric. So,
Okay.
What is an advancement in machine tools that you see coming in the future? What's something that you're excited about when it comes to the future of machine tools?
Yeah, so one thing I'm excited about with Mitsui Seiki is our Blue Arc roughing technology. So it's essentially like a wire EDM on steroids. It's using basically an electrode that's shaped similar to an end mill, but using electricity to remove material on heavy metals. So basically Inconel's titaniums. We see tremendous reduction in carbide. Obviously, there's no carbide used whatsoever for the roughing. And then for power consumption, it's very similar to an actual machining application. So it's not a huge draw on electricity. So we're really excited about that in the future right now.
Awesome. Thank you, Eric. So Ben, we'll go back to you with the same question. The future of machine tools, what's really getting you excited about what's coming down the pipe?
Well, it actually has more to do, for me anyway, it has more to do with the materials that we're cutting and the processes. And two examples are, I get more and more requests from customers to be able to do grinding in the machine, right? But a grinder is built completely different. It's designed and built to handle all the grinding swarf. When you dress the grinding wheel, you get all this grinding grit, which is horrible for a machine that's not designed to take it. It's going to tear up the chip conveyor. It's going to tear up all the way wipers. So a grinder is designed to handle that, and a turning machine or a milling machine is not designed to handle that. So we have already developed some technologies and some options to be able to handle that. Okay. And the second thing is we're seeing more and more of the composites, right? So you take a lot of missile components, missile bodies, they're composites, but conventional cutting tools and methods don't really work with a lot of the composites. You can't just throw coolant at it. So you have to be able to, for example, maybe have a vacuum attached to the cutting tool, not to the tool itself, of course, but to the cutting spindle to evacuate all this dust, let's call it, when you're cutting composite materials, right? So those are the areas that I think there's in the next 10 years, there's going to be a lot of work in that area.
Awesome. Thank you, Ben. So we'll go to Simon at the Sharon Group with the same question. As far as the future of machine tools, what is really getting you excited at the moment?
So the one thing that gets me excited, and I think about it when I see customer plans and what they struggle with, is with machine tools getting more efficient. Sometimes you talk 20-30% that you increase productivity. The customers at the end need less machine to the same parts of number of parts. So he generates a lot more sales from one machine that he did before, in some ways really substantial. And that at the same point, if the machine is not running, which should be as always the littlest percent as possible, by that time he doesn't create the revenue that he wants, and it's substantial. So I want to see, and I always talk about it because I compare it with other technology out there. It's like, hey, on my computer, if there's something doesn't work, 10 years ago, I opened it up, plugged it in, next thing, and 10 minutes later, you know, it was working again. So I want to see a similar approach in the machine tools. Today, you buy a replacement motor or a hydraulic unit, all the components that go into the machine, and to get it back up and running, you know, sometimes the downtime, I still think this is takes too long time. So I like to see a lot of advancements in that to do go to a plug-and play style where we have, if an individual component fails, we have to take it quickly off and put the next one in, and then if this is a hydraulic unit, for example, take it off site and keep the system running. It's about uptime, and if I can cut 1 or 2% gain efficiency even more up, we're getting to an area where we're up there at 95%. Where do you get the rest of it? You know, so it's getting tight, but these are the topics. Simplicity in a machine tool, easy maintenance, because this really brings the benefit to the customer. The rest of the topic, yeah, we tweak it here and there. I think we're technology capable of doing that, bring it to the edge. But these are the topics for the future that really matter to think about that. Yeah.
Thank you, Simon. Now, Thompson, we will ask you the same question as well at Anka. Future of machine tools. What is really kind of getting you excited about the future of machine tools?
Thank you, Jake. Yeah, at Anka, as I said before, we've released a product to the market called AIMS, which is Anka Integrated Manufacturing System. And we actually call this as the fourth industrial revolution. The reason behind it is, I mean, it's a fully automated cell with minimum dependency on highly skilled labor. That doesn't mean, you know, we are actually trying to get rid of the manpower or the labor, but we want the talent in the organization to be problem solvers rather than doing repetitive work like carrying material or feeding material into the machines and all this. So this one is a fully automated cell with minimum dependency. And this also has the IoT, which is the server, which is the brain of the system. So this is connected and it constantly collects data, and we get machine learning, and more data comes in and we automate the process based on that. So this has been released to the market and we have already started selling it and we have got good feedback. And so this is what we are going to be, I mean, we see this as the future of the cutting tool industry because everybody wants everything to be automated, depending less on skilled manpower.
Awesome. Thank you, Thompson. And then we will head to Jeff at Shute to wrap things up today. As Jeff, I ask you, with the future of machine tools, what is really getting you excited?
We've developed a new machine. It's called our ECX. Typically a multi-spindle machine. We've had 6 or 8 spindles, as everybody well knows. We've done a lot with the full CNC and Y-axis in all positions, yet it is a complex machine with many axes. The part quantities we've noticed are reducing. Your 1 million part runs, 2 million part runs are falling. People want shorter run lot sizes. And so what we've come up with here recently, and it's an exciting new machine. We've developed a machine with only 2 spindles, a main and a counter spindle. And we've used our multi-spindle technology to plant turrets, if you will, around those spindles. So now with our 2 spindle machine, we can bring 6 turrets to the part. So whether you have 6 spindles with 1 tool each or 2 spindles with 6 turrets, you still have 6 tools in the cut at one moment. However, a 2 spindle machine is much easier to set up. It's more productive for shorter runs, and it fits in that niche where you're dropping below the 1 million parts or 500,000 parts per setup. Now you can be productive at even 5, 10, 25,000 parts per setup and still get roughly half to 65% of the production of a full multi-spindle. So it's easier to set up, it's easier to maintain, it's easier to change the tooling, it's easier to do changeovers, and you yet get production far in excess of your standard CNC lathe. So it's a nice machine.
Great. Thank you, Jeff. Well, that just about wraps up our roundtable today, but I wanted to once again thank our sponsors as Anka, Mitsui Seiki USA, the Sharon Group, the Shute Corporation, Matsura USA, and WFL Milturn Technologies. And I couldn't also stop today without thanking all of our panelists, Eric, Ben, Simon, Thompson, Billy, and Jeff. So gentlemen, thank you so much for joining me today. Definitely learned a lot more about machine tools. So thank you for joining us from all of us here at GIE Media.
Thank you very much.
Thanks for having us, Jake.
You can find more Manufacturing Matters plus the MFG Radio Network's other podcasts on Apple Music, Spotify, Google Podcast, or on our websites at todaysmedicaldevelopments.com, aerospace manufacturing and design.com, and evdesignandmanufacturing.com.